And we finish our lecture today speaking about immunity. We'll talk about different types of immunity, their main characteristics and advantage and disadvantage for each type. And then we're going to finish our lecture talking about vaccines and vaccination as a process. And we'll talk about different types of, again, vaccines and their main characteristics. We start with the term that we have to know. It is immune tolerance. So what is it, immune tolerance? The immune tolerance is an ability of our immune system to distinguish self antigens from foreign antigens. It means its ability of immune system to recognize itself. What does it mean? Our own cells have surface antigens on the surface of the cells, and those surface antigens must be recognized by our immune system as a self-antigens. It means immune system not supposed to make antibodies against those self-antigens. So when immune system loses ability to recognize self-antigens on the surface of our own cells, then, as a result of this problem, patients develop what we call autoimmune disorders. And in our next lecture, we're going to talk about different types of autoimmune disorders. All right, immunity. What types of immunity we have to know? Immunity can be natural or artificial, but at the same time, it can be active and passive. So let's start with the natural active immunity. When you hear active immunity, it means immune system has to do its job. So that means B cells and T cells have to do their job, and they will be involved in this type. An example of active natural immunity will be immunity that is developed as a result of infection. Every time when we get infected, our immune system will make antibodies against that pathogen. And then, after we recover, we'll have immunity formed already against that pathogen. And next time, when we get exposed to the same pathogen, because we have memory cells formed already or immunity formed, we will not develop symptoms of infection. Now, advantage of active natural immunity. The advantage is usually this type of immunity is strong and long-lasting immunity. Disadvantage? We have to get infected, we have to get sick, develop symptoms of infection, and sometimes we develop complications, and complications can be very serious and life-threatening. Next type of immunity is active artificial type of immunity. Because in active, again, T and B cells will be involved, and an example of active artificial immunity will be immunity that is developed as a result of vaccination. To make a vaccine, regular vaccine, we use pathogens, dead or weakened. We introduce pathogens to the patient's system. Immune system recognizes those pathogens as foreign antigens and starts producing antibodies. Immunity. Advantage of this type. Usually, active artificial immunity is pretty strong and long-lasting immunity. If it's not strong enough or not long enough lasting, then we perform what we call booster shots and make that immunity stronger. Next type is passive and natural. Guys, passive immunity means antibody will be involved. And an example of passive and natural immunity will be the fact that immunoglobulin Gs can, for example, go across the placenta. And those are the first antibodies that actually child will receive from mother. Keep in mind, the newborn child has no immunity formed yet. It takes some time for immune system to get established, to get formed. So the first few weeks or few months, that child will be protected from with immunoglobulins that the child got from the mother. Another type of immunoglobulins that a newborn child will get from mother will be IgAs. Remember, IgAs can be found in the breast milk. So when child is on the breastfeeding, which is essential for a newborn child, then it means child will be protected by IgEs that that child will get from mother. Advantage of this type of immunity. The advantage part will be the fact that child is protected right away. As soon as that child gets antibodies from mother, child is protected. Disadvantage, short-term immunity. Those antibodies will stay in a child's system only for a few weeks or a few months, and then they will be gone. And that means by then, the immune system of the child must be formed and start working. And the last type of immunity is called passive artificial. Immunoglobulins that we introduce to our patients will be an example of passive artificial immunity. For example, guys, please remember, hepatitis B vaccine is actually immunoglobulin. So because immunoglobulins means antibodies are introduced to the patient's system, then patient will be protected right away. That is an advantage of passive artificial immunity. Disadvantage? Once again, this type of immunity is a short-term immunity. And the second, please remember, immunoglobulins are proteins, and some patients might develop allergic reactions to those vaccines. This slide once again repeats 4 types of immunity you have to know and their main characteristics. For example, naturally acquired active immunity. An example will be exposure to the infection. Naturally acquired passive immunity. Example can be immunoglobulins that cross placenta and immunoglobulins that newborn children get with the breast milk. Artificially acquired active immunity is an example. We can use vaccination. And finally, artificially acquired passive immunity. Example of this type of immunity will be gamma globulins or immunoglobulins. For example, hepatitis B vaccine that we introduce to the patient's system. Immunization. We use immunization to develop immunity in our patient system without disease. It means when we vaccinate our patient, we develop artificially acquired active immunity in the patient's system. Today in the market, there are 4 different types of vaccines that we use for our patients. The first type or kind is called attenuated vaccines. To make attenuated vaccine, we use alive microorganisms. Of course, we change them in the labs, we modify them, we make them weak, so they won't be able to cause symptoms of infection. But when we introduce them into the patient's system, immune system of our patients will recognize those attenuated pathogens as antigens and will start making antibodies. Second kind of vaccine that we have today on the market is inactivated vaccines. Inactivated vaccines are made of killed or dead pathogens. In this case, once again, pathogen is dead, inactive, but still will be recognized by immune system of the patient as a foreign antigen, and the immune system will start making antibodies. Next kind of vaccine is called acellular vaccine. To make acellular vaccine, we use exotoxins. Guys, we already talked about toxoids. This is another name for acellular vaccines. And I told you, for example, tetanus or diphtheria vaccines will be an example of toxoid. So basically, in this case, to make vaccine, we use exotoxins. And because exotoxins are made of proteins, they will be recognized by immune system of our patients as antigens. And when we introduce them, immune system will start making antibodies against those antigens. And the last type, we call them DNA vaccines. DNA vaccines are the latest one, the newest one, and the best ones. The reason why they're the best ones, because they do not cause allergic reactions. Why? Because to make those types of vaccines, we take just piece of DNA that encodes certain protein. We do not take protein to make those vaccines. And remember, protein is the very strong allergen for immune system of our patients. So when we're taking just piece of DNA instead of whole protein and use it to make vaccines, as a result, those vaccines do not cause any allergic reactions. No sickness. Speaking about acellular vaccines or toxoids, we also call it antitoxin. So once again, let's repeat it. Toxoid, it's a type of vaccine, we call it acellular vaccine, which is made of exotoxin. Why? Because exotoxins are made of proteins, which means very strong antigens for immune system. When we modify those exotoxins, make them weaker, and then introduce them to the patient's system, immune system of that patient will recognize those exotoxins as foreign antigens and will start making antibodies. And once again, example of toxoid vaccine will be tetanus vaccine and diphtheria vaccine. And this slide for you compares attenuated vaccines to inactivated vaccines. Let's talk about advantages and disadvantages for each kind of vaccine. As an example, we can use polio vaccine. Today in the market we have two types of polio vaccines, attenuated and inactivated. Attenuated polio vaccine is made of live polio viruses. We make them weak in the labs, so they will not be able to cause symptoms of infection in strong individuals. And then we introduce those weakened viruses into the patient's system. Because the virus is still alive, it still will be able to grow and multiply. And as a result, those patients usually develop a pretty strong and long-lasting immunity. This is an advantage of attenuated polio vaccine. But what is a disadvantage of this vaccine? Please remember, if your patient that you're going to vaccinate with attenuated polio vaccine is immunocompromised, or a person who takes care about that vaccinated child is immunocompromised, then those people can get infected with virus and develop symptoms of infection. Now, inactivated polio vaccine is made of killed polioviruses. So viruses are not active, and means they won't cause infections or symptoms of polio in immunocompromised patients. That is an advantage of inactivated polio vaccine. How about disadvantage? Unfortunately, killed polioviruses create or form short-lasting and weak immunity. And even with the booster shots, immunity not as strong, that actually is not strong enough to protect that child from infection. And finally, the last slide of this lecture gives you once again information about passive artificial immunization. In this case, we introduce immunoglobulins or gamma globulins in the patient's system, and those are antibodies. So, advantage of this type of immunization: child or infected or immunocompromised patient is protected right away. So again, immunoglobulins or gamma globulins protect our patients right away. And as I said, it's very important, especially for immunocompromised patients. Disadvantage, short term of immunity. Usually gamma globulins or immunoglobulins antibodies stay in the patient's system for a few weeks only, and then they will be gone. And another advantage of gamma globulins will be serum sickness or allergic reaction. Keep in mind, immunoglobulins, those are proteins, and as I said before, proteins are the strongest allergens for immune system of patients. So some of the patients can develop allergic reactions to those injections.